Yowzers, and welcome to the Daily Space Weather. Looking at a solar flare as a solar flare watch continues, and a new sunspot group grows and sets. Here is the sun in 131 angstroms from the Solar Dynamics Observatory, and you can see up here in the northwest an M-class flare happening. Peak flux was around 7:15 Universal Time on July 3rd. And whether or not a coronal mass ejection was caused by this solar flare or associated with it is yet to be known. We've got all kinds of missing data from the LASCO and the Stereo A spacecraft, so we can see some filaments moving here. You can see some filaments moving down to the south. Whether they've ejected the sun or not, I don't know, as I don't see any data on it yet. And we'll zoom in briefly on that northwest region. Here's a composite view, and we actually paused it here at the moment of peak flux. This composite image includes 335, 193, and 94 angstroms. Great view of that solar flare there from Sunspot 2838 if it's visible long enough from Earth to get a name. It might not have been there for 12 hours. Here's the formation of it. This is the intensity gram from the SDO. And the likelihood of additional significant solar flares from Sunspot 2835 remains. Check out how fast this sunspot suddenly formed up here in the northwest. I don't think it's going to get a name, folks, but that is essentially Sunspot 2838. Next, I'd like to thank our patrons who found out about this probably only minutes after it happened. But in any case, thanks patrons, the true source of funding for these videos. Patreon.com/smAsho is the URL to enroll yourself in some early alerts and multimedia and all kinds of other stuff. Yes, we provided our patrons already with graphically interesting images of the most recent solar activity, an M-class solar flare. So here's a diagram of the solar system. We'll advance this 1 week. There's where things will be in 1 week. At that point, Nibiru should be right about here. That's the location of Nibiru in 1 week. Here's a star chart. I like to face mine to the south and draw in the ecliptic, which is this yellow line, the path the sun will take across the sky. If you're up before dawn, you may see Jupiter and Saturn and Mercury and the moon up there near the ecliptic. The sun just rising here in Lehigh Valley, Pennsylvania. The 10.7 centimeter radio flux, the most proportional feature of solar activity to sunspot number, now at 95. Here's the 1 year chart of that. The black line is the radio flux, the red line is the sunspot number. No space weather storms or anything like that forecasted from NOAA at the current moment. There's the view from the Space Weather Enthusiast dashboard. A whole lot of nothing forecasted in terms of geo-effective space weather. Now, we'll probably make another video later today to let you know whether or not there was a coronal mass ejection associated with that M-class solar flare. Continuing on with the DSW video, looking at the 90-day chart of seismicity here on the planet, while we did see a 6 magnitude quake here in the past 24 hours, we're seeing a huge 7+ magnitude earthquake drought. If you're in an earthquake-prone zone, please have a plan. Expect an earthquake and be an asset, not a liability in the event of a disaster. Know which building facades may collapse. Have a bug-out bag. Tell your friends and foes that we're having an earthquake drought. Things like this. Anyway, there are the 4+ magnitude quakes, and there are the 6+ magnitude quakes. That 6, I think it was a 6.1, occurred in between the Tongan Trench and Fiji, southeast of Fiji and southwest of Tonga, north of New Zealand. Initially reported as a 6.1 here. I don't know if it was downgraded, and frankly, my dear, I don't give a damn. All right, so here we got a deep quake here at Vanuatu. Geysers, California saw a 300 meter above sea level quake there. It's only a 2.7 magnitude. The Kuril Islands there, south of Kamchatka, a volcanically active region, saw a 5.3 magnitude quake. Western South America saw at least one deep quake. A deep quake in the Aleutian Islands, a deep quake at Chile, a majorly deep quake at Fiji. That 6.1 magnitude quake was over 600 kilometers depth. And if that occurred at the surface, that would be over a 7 magnitude. That would be like a 7.5 magnitude quake, large enough to create concerns about tsunamis and so on. Again, that 6.1 magnitude Fijian quake happened at over 600 kilometers estimated depth. There's another deep quake in western South America at Chile. It's only a 4.0 magnitude, but over 120 kilometers depth. And an aftershock there at Fiji, a 4.2 magnitude, a little bit shallower, estimated to be about 585 kilometers. A little shallower, still extremely deep. That's farther down than the ionosphere is up. Dominica also saw a deep quake. And here's one in southern Mexico. Let's continue on with volcanic coverage. If you're wondering what volcanoes are erupting, well, Fuego's on the list. And here's an image of it sending some glowing lava blocks down its slopes. Here we are on volcanodiscovery.com. Let's scroll the list. Suwanose-jima exploded. Produced a volcanic ash cloud of unknown size. Don't fly your hang glider over the caldera. Semeru on East Java exploded as well. A discrete, and when I say discrete, I mean 14,000 feet above altitude volcanic ash cloud. Doesn't seem discrete to me. Fuego in Guatemala. Ash plumes above it reached about nearly 16,000 feet of altitude there. A near constant incandescence continues to be observed from the summit crater at the Guatemalan volcano Fuego. Telica in Nicaragua, volcanic ash not observed. Please don't square dance around the caldera. Revenador in Ecuador exploding. 17,000-foot ash plume produced there. Sabancaya exploding. 24,000-foot ash plume over Peru from the Sabancaya volcano, and Nevados de Chilean rounding out our list, producing explosive activity and intermittent emissions enough to produce a 12,000-foot ash plume. No matter how hopeless your day seems, please don't pole vault the caldera. To quote Winston Churchill, if you're going through hell, keep going. Don't become part of the lithosphere by immersing yourself in a lava lake. In other words, please do not pole vault the caldera. This public service message brought to you by smAsho.com and our YouTube channel. Here's the X-ray environment over the past 3 days. And you can see 2 significant C-class flares and then this M-class flare. The peak flux was at about 7:10 universal time. So if you want to go look up imagery of that, 7:10 was the peak flux moment. Now, solar flares have the ability to create radio blackouts by creating ionization and polarization in the ionosphere. So here's the deabsorption region data, and there's your radio blackout. It occurred right over India, which is about where noon was. This will tell you about where the sun was located over planet Earth when a solar flare occurs. And yes, solar flares affect radio communications pretty much without warning, as we don't really have very much ability to forecast solar flares, except by mainly by evaluating the magnetic field environment. Pretty much the only way we can forecast solar flares at the moment. And don't get solar flares and coronal mass ejections confused. They're completely different phenomenon. Solar flares are photons photons of X-ray energy. Coronal mass ejections are protons. So there you can see those two C-class flares happening as well. And then this M-class flare. Don't be surprised to see additional large flares, especially from Sunspot 2835. It's just moved out of the Earth-facing quiet zone. It's just moved out of the Earth-facing quiet zone. So don't be surprised to see additional M-class flares. We did not expect an M-class flare to come out of a sunspot that didn't even exist yesterday. Sunspot 2838 was a surprise to all of us. So we don't see any proton strikes yet. An indication that a coronal mass ejection may not have happened, or may not have happened at least directing any protons toward planet Earth. None showing up on the GOES 16 proton flux. Here's the 3-day chart of the GOES magnetometer. Apologies for not showing that the last couple of days. Occasionally we use a tab for something and then I forget to put it back. So anyway, there's the GOES magnetometer. And there's a bit of you can expect some sawtooth patterns showing up here. Some pretty wild spikes in the GOES magnetometer as a result of the polarity of the current sheet. There's a bit of a polarity tug-of-war going on between the north and south polar fields. They can't decide which one's in charge of the Earth portion of the current sheet. So here's a visualization of it. You're seeing North Pole polarity in green, South Pole in red. Keep in mind the data is 1 hour and 24 minutes old from when we made the video and can change with absolutely no warning. Here's a line of sight view of the same stuff. It also shows you the solar magnetogram. And next we'll show you the coronal hole line of sight plot. We've got quite a few coronal holes here, so there's a lot of features right now in the Earth-facing portion of the solar disk. We've got south and north pole coronal hole systems reaching all the way down beyond the solar equator, some mixing of coronal holes, which could create things like co-rotating high-speed coronal hole wind streams. And here's some more imagery. Detected coronal holes and sunspot groups. So yesterday we showed some overlapping of north and south pole oriented coronal holes right on the solar equator. Today some of those seem to have subsided. And by the way, this sunspot up here is most assuredly a beta class sunspot. And feel free to leave us a comment if you've got theories as to whether it'll get a name. I don't think it's going to be Earth visible for long enough to be there for 12 hours, so I don't think it's going to get a name. It should be called Sunspot 2838, but it all has to do with naming conventions, folks, because keep in mind, Galileo wasn't quite as good at seeing sunspots as we are. We've got a little bit more advanced equipment. Global geomagnetism as expressed by the planetary K index, the KP at 2. Geomagnetic calm conditions. Let's take a look at the real-time solar wind. And we've got some possible errors in the real-time solar wind. If you see these yellow bars down here, that represents suspect, as some of these really mechanical-looking gyrations here are not particularly believable. And there is code in there to suggest when there could be some data problems. It could be caused by things like cosmic ray flux. And we'll cover cosmic ray flux updates in a later video. Anyway, current conditions are slightly elevated solar wind speed here, 459 kilometers per second. Solar wind density just under 5 protons per cubic centimeter. Here's 4 hours of geospace magnetosphere movie. It's the magnetohydrodynamic environment surrounding planet Earth as modeled by the Space Weather Modeling Framework, which uses a lot of variables. If you want to read about it, go to the Geospace Magnetosphere Movies page, scroll down to the bottom, click on Details, and you can read all about the Space Weather Modeling Framework that generates this model. Here's another model from the Space Weather Modeling Framework. Ground magnetic perturbations, or geospace delta B, changes to the Earth's B field. And like the Geospace Magnetosphere Movies magnetohydrodynamic pressure, we show this daily on the Daily Space Weather videos. as the data is not yet accessible in archival format that we're aware of. Hopefully that will come soon, or at some point in the future. We're going to let this play through a second time here as we see some anomalous magnetic field gyrations happening. Pulses coming out of the Pacific Ocean here. You can see there northeast of Australia in the Pacific Ocean. Perturbations south of South America, as well as southwest of Alaska there, in between Alaska and Antarctica, as well as perturbations over the Canadian and Siberian North Geomagnetic Poles. If you're wondering where the South Geomagnetic Pole is, it's someplace down here. And there's a North Pole over Canada and a North Pole over Siberia. Yes, the North Geomagnetic Pole has split into two, and the South Pole has left Antarctica entirely. Anyway, let's continue on. And thank everybody for tuning in. Don't forget to press like and subscribe if you enjoy the content here on YouTube. And don't forget to visit our own page, smAsho.com, visit our social media links, leave us a comment, press share, etc. Thanks to our new YouTube subscribers. We're also on BitChute, more exclusive content coming there soon. We're also on Discord. Again, another reason to check out smAsho.com is to find our Discord chat. Anyway, welcome to the Neo Renaissance. smAsho.com, smAsho.org will redirect you. And since it is a holiday weekend, Independence Day weekend, I'm inviting you all to Mansa. If you click on the smAsho store link, you'll be directed to our Teespring store. And today's featured product is the Mansa shirt in purple. Why? Because I'm wearing one right now. Yes, Mansa. Which is, by the way, completely apolitical. It stands for Make America Not Suck Again. Have you noticed that America has been sucking since last year? Yeah. I certainly have. So anyway, the point of the Mansa shirt is that it's up to you to make America not suck again. I bought it in purple because that's our cycling team colors, purple and gold and black. Perhaps pick one up in orange, because nothing says don't run me over or shoot me like a blaze orange piece of clothing. Anyway, this 4th of July weekend, make sure that you, Mansa, make America not suck again. Since it's up to you, not the government. By the way, we've got tons of cosmology segments. Check out our playlists, youtube.com/smashamash/playlists for our cosmology segments. Today's will be a separate video. Next, looking at the electron scenario around planet Earth. Electrons are rather important because they're a very light particle. They're not massive. They react to magnetic fields before anything else that we're measuring extensively. Here is the charging hazard scenario around planet Earth. Electrons can charge up satellites, and we see some minor surface charging hazards here over places like Mexico and the South Central Pacific. No big deal. Here's the 1-year chart of the greater than 2 mega electron volt electron fluence from Solon.info. Here's the 3-day chart. We're just in a moderate range here, nothing to write home about. Here's the forecast model. I have no complaints or arguments or refutations of that. And here is the total electron content forecast showing you the electron density for the entire air column of planet Earth. And we are seeing some anomalous, chaotic electron belts here happening, giving us insight into Earth's magnetic field, because once again, let me reiterate, electrons are like 1/1200th of the mass of a proton. They react much more readily to phenomena such as magnetic fields. And this is the reason why we show the total electron content forecast. It also shows you where GPS errors are likely to be located, as your GPS must communicate between large blobs of electrons if you're around the equator at noon, which causes massive GPS errors. Here's a diagram of the Van Allen belts. We show it for reference on the daily, and we're going to show the ionosphere as well. Let me just press reload. The F ionosphere is one slice of the atmosphere located here at about 300 kilometers of altitude. And you're looking at vibrational frequency. in megahertz, millions of vibrations per second. We've been noting some highly anomalous ionospheres, ionograms, in the past few days. More like the past about 2 weeks. It's looking a little more normal here. It looks like the ionospheric anomalies are subsiding a bit. Here's the latest image from 10 o'clock Universal Time. Things looking fairly normal, if not a little bit low vibration at that moment. Only making it up to about 8 megahertz at that moment there, 10 Universal Time. And again, there's where the F ionosphere is located. This diagram also shows you temperatures of the thermosphere at solar minimum and solar maximum, penetration of electromagnetic radiation into Earth's atmospheric layers, and altitudes of different portions of the ionosphere, such as the D, E, and F layers. And just in case I failed to show those graphics, there are the charging hazard graphics. There's the 1-year chart of the electron flux. There's the 3-day chart. Feel free to pause the video. We've got to keep moving. Here's the electron forecast. And here's the total electron content. I'll let this play through for one run. I apologize if I showed a test pattern. It happens. We don't edit the videos to get them out as quickly as possible, as they are largely time sensitive. There's 10 o'clock Universal Time in the ionosphere, and there's the diagram with the layers. Again, feel free to pause the video if you must. Hey, that's an awful nice space weather video you got there. Be a shame if it had bonus features, eh? Here's the latest hydrogen alpha imagery in 6,562.8 angstroms from the El Teide ground-based solar observatory from El Teide, Spain. There are still a lot of filaments in the Earth-facing portion of the solar disk, an indication that perhaps a coronal mass ejection has not occurred. That would be my best guess. What I'd really like is to be able to see the data from Stereo A and the SOHO. But since I can't, here is the data from the GOES 16 SUVI in 284 angstroms. And you can actually see the solar flare sort of subsiding right at the beginning of this. It took us a while to do show prep today, as there was a lot of stuff to talk about. Here's the latest intensity gram. Largest sunspot is Sunspot 2835. Sunspot 2836, which is this one down here, has degraded to an alpha class sunspot. Sunspot 2837 is still beta class and still does harbor the sort of fields required for significant solar flares. And Sunspot 2838, if it ever gets named, popped up out of nowhere in front of a plage here. You can see this light area. That's the plage. This just spontaneously formed, this sunspot. I'm sure it's beta class. Let's check the magnetic fields. Quite sure that there is a north and south pole oriented set of umbrae there. Anyway, here are the fields of 2837. Here are the fields of 2835. It is major. Don't be surprised to see more M-class flares come especially out of this, now that it's out of the Earth-facing quiet zone. Expect to see more solar flares, period. All right, so here's some more solar imagery from the Solar Dynamics Observatory. This is 1600 angstroms, which is ionized carbon. And we're showing this for a specific reason. The lightest areas are the areas with the most carbon. And I ask you, the viewer, is that because of fusion occurring on the surface of the sun, or because the sun is encountering dust? Now, I certainly have an idea on this. I won't offer it up in the video. But here's an image of a sudden brightening. In other words, lots of carbon in that area. What's up with that? Is it because of fusion happening on the surface of the star? What's that? We don't need supernovae to create the heavy elements, folks? Yeah. You don't need supernovae to create the heavy elements, folks. It's happening on the surfaces of stars. And another consumer tip is that supernovae do not appear to destroy stars. When we look at the cores of supernoval remnant shells, we tend to see stars in the centers of them. Yeah, stars, that's right. We'll close out today's daily space weather video in 171 angstroms and colorized magnetogram. Another composite here from the Solar Dynamics Observatory. Thanks for tuning into the daily space weather. We expect to make at least one more video today. It may be about why sunspots are dark, featuring guest Eugene Bagashov. Make sure you subscribe to Eugene the Philosopher. Eugene the Philosopher, yes. Make sure you subscribe to his channel. It's fantastic. I think he's approaching 300 subs now. Let's get him to 1,000 so we can monetize his channel. And thanks again for tuning in for the daily space weather, folks. May that solar wind be at your back.